So exactly from where we stop, I was just trying to differentiate some key differences between alkane and alkene. Now, another difference between them is that the general formula for alkane is CnH2n plus 2, while the general formula for this one is CnH2 what? H2n. Now, I can generate the member of alkane now, just like by following the formula. I told you n is from 1, where n is from 1 to what? To infinity. So when n is 1, let's put it here now. When n is 1, as we're having C1, then H2 into bracket what? Into bracket 1. So which way you can have CH2. So this is the smallest alkane. We call it methane. Methane. Some of the textbooks will not carry this one. Some of the textbooks will not carry this one. Because if you have to, there's no structure for this, and that is why most of the textbooks is. So I can say the smallest alkane family now is 18. So let's get that one now, 18. So I'll be having C2, that is when n is 2. 18. Then I'll be having 2 bracket what? 2 bracket 2. Therefore, I will be having CH4. So this is 18. So we can say the first, sometimes we say the first member of alkane family is 18. Why? Because methane has a name but does not have a structure. So how do we draw this one now? How do we draw? You can see that I have C, then here I have the double bond. Then I have here H. You can see that here is open, and that is the effect of the double bond here. So 1, 2, 3, 4 for H, 1, 2 for C. We can rewrite this thing as CH2, the double bond, another CH2. So this is the structure for what? Ethane. This is the structure. Either you draw this or you draw this. So this is the double bond we're talking about. So when you follow another family of alkane, there is always a double bond. Let me pick the next one. So the like of propane, which is the third one now. Propane, follow the formula. I'll be having C3. I think I'm right. Then H2 bracket what? 3. So I'll be having C3, then I'll be having H what? 6. So let's see. I can have C. You can decide to put your double bond here or you put it here anywhere. Just put your double bond anywhere. Then here I can have our C complete here. Then I have C here. Then I have C here. So I am trying to draw for C3, H6. So then I have C here. I have C. If you count the number of H, is already 6. 1, 2, 3, 4, 5, 6. So here is open, here is open. And that is the effect of the double bond we have here. So if you put your double bond here as well, here is going to be open, here is going to be open. This one is going to be what? Complete. So that is how we can generate the other member, and that's how we can draw the structure of alkane. So I've been able to look at alkane. So you can, from the 2 I have drawn, to learn how to draw the remaining one. I've been able to draw for this at all. So this one, I can write this one as CH3, then CH, then CH2. That's another structure. So whether you see, if I say draw a structure for alkane, for ethane, is either you draw this or you draw this. So draw a structure for, propane. Draw a structure for propane. Is either you draw this or you draw this. Draw a structure for ethane. It is either ethane is like this or ethane is like this. So you can, from the methane, ethane, learn the other family of alkane and how we can draw their structure. You can, from ethane and propane, learn the other family of alkane and how we can draw their structure. So the third one I'll be taking on, and just follow the method and follow the formula. So you can, the structure is always very simple. And the name is also very simple, where you just follow the general formula. So the third hydrocarbon I'll be treating is alkyne. Alkyne. So that's the third one, alkyne. Alkyne is the third one. So this is the third one. Alkyne. Alkyne. That's the third one. Now, difference between these two has been noted. So this one almost have the same property with this. This one is unsaturated. I've told you the reason, because the number of hydrogen is not complete around the C. This one too is unsaturated, because the number of hydrogen here too is not what complete. Another thing we should know about this one is double, or this one form double bond, i.e. 2 lines, while this one form triple bond, i.e. 3 lines. So you can see that here is open, here is open, here is open, here is open. So in this type of, but if it is under alkane, it is only here that is open, or here and here. But here is connected to, these two places are connected to hydrogen. But in alkyne, 1, 2, 3, 4, that 4 part have just touched, they are all open without any connection to what? To hydrogen. So this one is triple bond, this one is double bond. So this one form, the hybrid for this one, like I've said, sp squared, while this one is just what? Sp. And because P has no power, so the name of the structure is what? Linear. This one is trigonal. This one is tetrahedral. Tetrahedral, trigonal, what? Linear. Sp cube, sp squared, and what? And sp for what? Alkyne. So now the general formula for alkyne is Cn H2n minus 2. This one is Cn H2n plus 2. This one is Cn H2n. That's for alkene. While this one, alkyne, is Cn H2n minus 2. So by the time you follow this formula very thoroughly, you will be able to generate all the family members of alkyne formula. N start from 1 to where? To infinity, as we are used to doing. So let's get the first one now. Let's get the first one. So when n is 1, C1, then I have 2 into bracket 1, then minus 2. So I'll be having C, then H0. Because 2 times 1, that's 2. 2 minus 2, that is 0. So which means there's nothing like this. And that is why alkyne has no member called methyne. Because in methyne we have ordinary word C. So alkyne alkyne family has no member that can be called methyne. So let's try the second one now. Ethyne. When that is when n is 2. So I have here. So C2, this is 2 times 2, 4, and then this is 4 minus 2, that is 2. So I'm having H2. So this is the second family of alkyne, and it is called ethyne. So this one too has no base in chemistry, because the number of carbon is the number of what? Hydrogen. In fact, the triple bond cannot even go for this structure. In that case, we can consider this one too as something not in existence, just like methane. So I can say the existences of the family of alkyne begin from the third one, and that is where? Propyne. So let's see for propyne when n is 3. So I'll be having C3, H2 times 3, then minus 2. Then I'll be having C3, this is 2 times 3, and that is 6. 6 minus 2, that is what? 4. So C3, H what? H4. So I can say the existence of alkyne family became from propyne. So this is the formula for propyne. And let's see how the structure look like. So we continue from the next class.